This week at NASA. Space Shuttle Endeavour made its final move from the orbiter's processing hangar to the vehicle assembly building at the Kennedy Space Center. This activity, called a rollover, was followed by Endeavour's mating to its external tank and twin solid rocket boosters, already on the mobile launcher platform. During the 14-day STS-134 mission, Endeavour's crew, commanded by Mark Kelly, will deliver to the International Space Station the Alpha Magnetic Spectrometer, as well as communications antennas, a high-pressure gas tank, and spare parts. Targeted to launch on April 19th, STS-134 will be the 36th shuttle mission to the International Space Station and Endeavour's final scheduled flight.
I've seen it now within the administration. Still, we've got work to do to really connect our whole budget.
Deputy Administrator Lori Garver completed a whirlwind tour of NASA facilities in California, updating the Golden State Centers on the President's fiscal year 2012 budget proposal for the agency. Garver participated in town hall employee presentations at the Ames Research Center in Northern California, the Dryden Flight Research Center at Edwards Air Force Base, and the Jet Propulsion Laboratory in Pasadena. She also met with the Glory satellite launch team at Vandenberg Air Force Base. During her two-day trip, the Deputy Administrator explained how NASA's 2012 budget requests aligns with the directives Congress laid out for the agency in the 2010 NASA Authorization Act. Garver also said NASA will continue to support the International Space Station, stabilize the aeronautics budget, emphasize space technologies, and develop new exploration systems.
And now, centerpieces.
If you gradually apply enough pressure to a soda can, it will eventually ripple and collapse. That's similar to what a team of NASA engineers at the Marshall Space Flight Center will do to an immense cylinder simulating a rocket fuel tank. They hope to generate new shell buckling data from which lightweight, safe, and sturdy skins for future launch vehicles can be designed.
Why it is critical is if we are building structures too heavy, like we have in the past, we're not going to be able to get the payload into space like we want to.
The 27.5-foot wide, 20-foot tall aluminum lithium cylinder will be sandwiched between two massive loading rings. Sophisticated cameras and sensors will record how and where the test article buckles as it's subjected to almost 1 million pounds of force.
During this shell buckling testing, we also integrated a new method of seeing strains and seeing displacements using video image correlation, also known as VIC. VIC utilizes black dots on a white background on our test article, and using high resolution cameras we'll be able to see the test article in 3 dimensions and be able to actually show real time during the load application, during test, such things as displacements and full field also.
Researchers believe data from this first full-scale shell buckling knockdown factor test will help update essential design calculations made during the Apollo era, well before the advent of modern composite materials, manufacturing processes, and advanced computer modeling. In turn, that should lead to the design and production of lightweight, safe, and cost-effective structures like the main fuel tank of a future heavy-lift launch vehicle. Targeted for late this month, the test is being led by the NASA Engineering and Safety Center with the support of Langley researchers and Marshall engineers.
NASA's Kepler team celebrated the midpoint of their 3.5-year mission to search for Earth-sized planets around other stars in the galaxy. The occasion brought together many of the dignitaries whose efforts helped to make the mission successful. The event followed major recent announcements from the Kepler science team, including the first confirmed extrasolar rocky planet, as well as the flattest, most compact multi-planet solar system found to date. The celebration also coincided with the Kepler Science Operations team receiving their award for NASA's Software of the Year. The success of the mission so far inspired team members to reflect on the importance of Kepler in the context of human history.
This is a celebration that's larger than just a single mission, just a NASA mission, just a bunch of scientists getting together. This is a mission that's answering some of the most fundamental questions that every person wonders about at night when they look up at the stars.
The night was a rare opportunity for the diverse Kepler team to raise their glasses and toast their achievements, both past and present, and to acknowledge high expectations for future discoveries to come.
We have a team of 4 over here, you're team 5. Team of 3 is team 6.
24 teachers became students for a week during the Virginia Aerospace Science and Technology Scholars Teacher Institute. The institute, held at NASA Langley Research Center in Hampton, was designed to give educators the tools they need to bring the excitement of NASA content to their students.
This time we have 25 STEM teachers, so science, technology, engineering, and math teachers that are coming to us from across the state. They are high school teachers, and they're coming to us for the week to learn about NASA materials curriculum that they could integrate into their classroom. We are using Mars as a context, planning a Mars mission, much like the Summer Academy for the students.
Teachers heard from planetary scientists and engineers who actually worked on Mars missions. They also had the opportunity to work with NASA multimedia materials and create their own podcasts. For technology teacher Octavia Williams, this opportunity was too good to pass up.
It's very important, and it was so important that, I had to miss like 3 days of class.
During a penny hauler game, teachers were challenged to build a propulsion system that would haul the most amount of pennies the farthest. They were given pretend money to buy materials and only a certain amount of time to build their system. The team that carried the most pennies the farthest for the least amount of money won.
The past day and a half, they've really learned about the science. Today, they're learning about the engineering and the engineering design process. And what we're trying to do with this week is give them activities and have them actually do activities that they could easily take back to the classroom.
For many of these teachers, the Institute offered them a fresh perspective and introduced them to new ideas.
Oh my gosh, it's fabulous. I just can't get enough of it. We've only done 2 days and I could go back with so much stuff to use in my classroom. Still got 2 more days to go, so I'm really excited.
And that's This Week at NASA. For more on these and other stories, log on to www.nasa.gov.